Hello dear students, I think you are doing good. And today I want to explain you something about one-sided limits. Some of you having problems with solving exercises on homework assignment, so now I'll try to explain. In this section we extend the limit concept to one-sided limits. You already know what is the limit, and it's the limit that we learned already and you were solving some exercises there. It was two-sided limit, but today we'll learn what is one-sided limit, which is we call left-hand side limit and the right-hand side limit. Sometimes the function f can fail to have a two-sided limit at a point. It may still have one-sided limit, that is a limit if the approach is only from one side. If the approach is from the right, the limit is a right-hand limit. From the left, it is a left-hand limit. Right-hand limit can be written in this form. Limit x tends to c from right side. If it's right-hand limit, you have to write here plus f of x is L, or limit x tends to c from left side, f of x is m. It is better to explain this with graph, as usual. Okay, here's the graph of the function. This is the function f of x. This blue line is function f of x. Blue line is function f of x. This is x-axis. We are saying that limit x tends to c from right side, f of x is L. When x tends to c from right side, the function f of x, this blue line, tends to which number? The number L, because this distance is L and L will be at this point. We cannot find the limit from the left side at point C, because the function is not defined here. It has no domain here. It's not defined. Look, there is no graph. So this function f of x cannot have limit at point C. It just has one-sided limit from the right side. Another example for the left-hand side, the similar function f of x, and it's defined until this point, the point C. It is not defined outside of this point, like right part here. These points we have like c plus 1, c plus 2, c plus 3, and all other numbers, etc. All other numbers are not included in its domain. So we only can consider left-hand side limit. Limit x tends to c from left side. X tends to c from left side. And the f of x, the blue line, tends to which number? It tends to number m. This distance is m, so this point will be here. It will be m, this point. This is m, so we call this limit when x tends to c from left side, f of x is m. The domain of function f of x equals to square root of 4 minus x squared. What is a domain? We know how to find its domain. This is square root function and it must be positive and it can be equal to 0. It cannot be negative. So how to find its domain? 4 minus x squared greater than or equal to 0. If we solve this inequality, we will find that x is between negative 2 and 2. Negative 2 and 2 are included. Let us look at the graph of this function. The graph itself says that x-axis, y-axis, and the function f of x, this blue line, is function. If we look carefully here, this function is not defined outside of 2, this part, or the left side of minus 2. it may have limit only in this area, only in its domain. 3, if we have here like the point 3 is not included in its domain. F of x is this function, square root of 4 minus x squared. Is not defined, does not exist. Because the number 3 is outside of domain of this function. But how about number 2? When x tends to 2, from left side, the function has values, this blue line we can consider from left side. But how about from right side? Can x tend to 2 from right side? No, because it means when x tends to 2 from right side, it must be 3, 2.5, 2.1, or some other numbers. If you plug in this number here, instead of x, like 2.5, 4 minus 2.5 squared. So the number here will be greater than 4, and the square root of this expression will be negative. It's impossible. So limit when x tends to 2, f of x does not exist. Does not exist. Limit when x tends to 2 from left side. This function has limit. So it means we have to plug in this number to here. 4 minus 2 squared. 2 squared is 4. 4 minus 4 is 0. Square root of 0 will give me 0. It's the same with negative 2. So this is the left hand side limit. So we can write here this expression. Limit x tends to negative 2 from right side. It can tend only from right side. This expression is 0. And limit x tends to 2 from left side. 4 minus x squared equals to 0. This is the one-sided limit. The theorem says a function f of x has a limit as x approaches c if and only if it has left hand and right hand limits there, and these one-sided limits are equal. So in order to a function have a limit, this one, there are two conditions. First of all, it must have left hand side limit at this point and right hand side limit at this point, and both are equal to each other. If this is L and that one is L, we can write this one. Okay, consider next example. It says to me that for the function graphed in figure 2.27, the figure 2.27 graph of the function in example 2, okay, at x equals to 0, we have to find limit x tends to 0 from right side. From right side, x tends to 0 from right side. The function tends to number 1. That's correct. Limit x tends to 0 from left side. From left side. Does not exist. There is no function, because the function is not defined to the left of x equals to 0. Limit x tends to 1 from left side. X tends to 1 from left side. From left side, x tends to 1, and the function tends to 0. Correct. To f of 1 is 1, but f of 1, if we plug in 1 here, it is equals to 1. Limit x tends to 1 from right side. X tends to 1 from right side, from this part. The function tends to 1. Limit x tends to 1, f of x does not exist, because x tends to 1 from left side equals to 0. X tends to 1 from right side equals to 1. They are not equal. Because of the this theorem, if they are equal, we can write this limit. If they are not equal, so we will say limit x tends to 1, f of x does not exist, DNE. And other examples are explained in the same way. You have to read this book carefully. Finally, the precise definition of the limit. We say that f of x has right-hand limit L at c and right limit x tends to c from right side f of x equals to L if for every number epsilon positive there exists a corresponding number delta positive such that for all x c less than x less than c plus delta, hence the absolute value of f of x minus L is less than epsilon. And the same way we say that f has left hand limit L at c and right limit x tends to c from right side f of x equals to L if for every number epsilon positive there exists a corresponding number delta positive such that for all x these two conditions holds. Here's the graph. It says that x must be in this interval in order to have the f of x to have the limit L. X must be in delta interval and the limit will be in epsilon interval. In example 3, it says to us, prove that limit when x tends to 0 from right side square root of x is 0. Let epsilon positive be given to us. Here c equals to 0 and L equals to 0. C is this one, L is this one, we know this. So we want to find a delta positive such that for all x 0 less than x less than delta. 0 is less than x and x is less than delta. Hence absolute value of square root of x minus 0 less than epsilon, and from this one I can write this one because square root of x minus 0 gives us this, and square root of some expression it is always positive, so we can drop this absolute value signs. Go further. Squaring both sides of this last inequality gives to me x less than epsilon squared, this one. If 0 is less than x, 0 then if 0 is less than x less than delta. If we choose delta like x squared, we have this expression, hence square root of x is less than delta, or 0 is less than x less than epsilon squared, and absolute value of square root of minus 0 is less than epsilon. According to the definition, this shows that when x tends to 0 from right side, the limit of square root of x is 0. Limit of theta tends to 0, sine theta over theta is 1. We will use this theorem a lot of times. We'll need this one. This is one of the main theorems. For example, here, in order to solve this, limit h tends to 0, cosine h minus 1 over h equals to 0. How to show this? Here we have to use half angle formula for cosine h. We know the formula. Using the half angle formula, cosine h equals to 1 minus 2 sine squared h over 2. We can calculate limit h tends to 0 cosine h minus 1 over h equals to limit h tends to 0 minus 2 times sine squared h over 2 over h. Where I got this minus here? Because it was cosine h minus 1. But cosine h is itself equals to this one. 1 minus this expression. Here we have 1. This one and this. They are gone. So we got just minus 2 sine squared h over 2. And here, this 2, number 2, goes down here. And from this part, we can say theta equals to h over 2. we'll replace h over 2 by theta, sine theta over theta times sine theta. This expression, according to the theorem, is 1. This expression is 1. And when theta tends to 0, this expression sine theta is 0. Minus 1 times 0 is 0. And the next one, b, limit x tends to 0, sine 2x over 5x. It is 2 over 5. How? Equation 1 does not apply to the original fraction. We need a 2x in the denominator, not a 5x. We produce it by multiplying numerator and denominator by 2 over 5. So limit x tends to 0, sine 2x over 5x equals to limit x tends to 0. We multiplied both parts by 2 over 5. And here I will get this 5 and this 5. They are gone. And I got here 2x, sine 2x. This 2 over 5 can be written here according to the constant multiply formula, the rule. We have this, and sine 2x over 2x. If I say theta equals to 2x, this will be sine theta over theta. That gives me 1. 2 over 5 times 1 is 2 over 5. And the next example, find limit when t tends to 0, tangent t times secant 2t over 3t. This one. And from the definition of tangent t and secant 2t, we have 1 over 3 times 1 over t. I got this outside. Tangent is sine t over cosine t. But the secant is 1 over cosine 2t. And look here, we have sine t here and the t. So I'll have this expression, and 1 over cosine t, 1 over cosine 2t there. 1 over 3 can be written outside of limit. So 1 over 3 times limit t tends to 0, sine t over t. According to the theorem, it's 1. When t tends to 0, replace this t by 0. Cosine 0 is 1. 1 over 1 is 1. Cosine 2 times 0, because t tends to 0. 1. 1 over 1 is also 1. So if we multiply this 4 together, I will get 1 over 3. And for you, my dear students, you have to solve these exercises here. Which of the following statements about the function y equals to f of x graphed here are true and which are false? A. X tends to -1 from right side. -1 from right side. When x tends to -1, the function tends to 1. That's correct. True. Next one. Limit x tends to 0 from left side. F of x is 1. X tends to 0 from left side. From left side, the function tends to 0. It says 1. No. This is false. This is false. You have to consider all other examples here in the same way. Let us go further. Exercise 3. The function f of x given in piecewise form. This is piecewise function. If x is less than 2, it is calculated using this formula. If x is less than 2, this graph. If x is greater than 2, it is calculated using this formula, this part. Find limit x tends to 2 from right side. X tends to 2 from right side. Okay, if x tends to 2 from right side, we have to consider this graph. X tends to 2 and the function tends to which number? And from right side, we can calculate using this formula also. We have two ways. Find it using the graph or using this formula. If x tends to 2 from right side, it will be second case. Plug in 2 here. 2 over 2 is 1. That's correct. 1 plus 1 is 2. So this point must be 2. And limit x tends to 2 from left side. From left side. The function tends to this point. It tends to this point. And if it tends to 2 from left side, the graph says we have to use this first formula. 2. 3 minus 2 is 1. And this point is also 1. So we've done with the first one. You have to solve other exercises in this form. Finding one-sided limits algebraically. Consider this example. Limit x tends to 1 from left side. How to calculate this kind of limits algebraically? First of all, we have to be sure that 1 or the left side of the 1 is in the domain of this function. What is the domain of this part? It says x is not equal to -1. And this one, it says x cannot equal to 0. Cannot be equal to 0. Because they are in denominator. So x tends to 1 from left side. It's okay, it's in the domain. We just have to plug in here. Equals to this one, this, and this one. I took them from here, x tends to 1, and I plugged in to the formula. Equals to 1 plus 1 is 2, 1 over 2, times 1 plus 6 is 7, 7 over 1 is 7, 3 minus 1 is 2 over 7 itself. They are gone. They are gone. 1. You have to calculate all the exercises in this form. Good luck.